Hey guys, so today we're going to go over elastic collisions. What are elastic collisions? Elastic collisions are collisions where momentum and kinetic energy are conserved. If either is not conserved, the collision is inelastic. So we have two equations today, the conservation of momentum and the conservation of kinetic energy. Okay, so on to the problem. This is from chapter 6, page 198, number 51. Billiard ball moving at 5 meters per second strikes a stationary ball of the same mass. After the collision, the first ball moves at 4.33 meters per second at an angle of 30 degrees with respect to the original line of motion. A. Find the velocity, magnitude, and direction of the second ball after the collision. B. Was the collision elastic or inelastic? Okay, so first we're going to draw out the problem of ball number 1 cross direction. That's how it would move that way, 5 meters per second. We have ball number 2 sitting down here, 0 meters per second. Okay, and then once the collision would happen, ball number 1 would move like this. One angle it would create would be 30-degree angle, moving at 4.33 meters per second. Okay. And what we're solving for is ball number 2. Ball number 2. Okay. We're going to solve for theta, which is the angle at which it would move away from the original line of motion of 1, and the speed. So v2 final. Okay. So for this problem, in order to solve for the velocity, we're going to use the conservation of momentum equation, and we're going to split it up into its x and y components, so two components. So initially for ball 1 is moving just in the x direction to the right at 5 meters per second. Okay. For ball 2 is not adding anything in the x or the y direction because its velocity is 0 meters per second. And for ball 1 after the collision, it's moving like this, 4.33 meters per second. It creates an angle of 30 degrees from the original line. It would move without the collision. So we're going to split that up into its x and y components. So for the x component, it would be 4.33 cosine 30 degrees. And for the y component, it would be 4.33 sine. So first we're going to start off with the x component. Okay, so we're going to start off with the conservation of momentum equation. So m1 1 plus m2 v2 m1 v1 final plus m2 v2 final. Okay, all the billiard balls are of the same mass, so we can cancel out all the masses. And v2 is equal to 0, so we can cancel that out. So we have v1 equals v1 final plus v2 final. Okay, v1 initially is 5 meters per second. v1 final, we're going to take the x component of that, so it's going to be 4.33 cosine 30 degrees. Okay, plus v2 final, which we are solving for, and we just subtract. So 5 minus 4.3 cosine 30 equals v2 final. That comes out to 1.25 meters per second. That's in the x direction for ball 2. And then now we're going to go to the y direction. Okay, we're going to do the same thing. We're going to use the same equation, m1 v1 plus m2 v2 equals m1 v1 final plus m2 v2 final. Okay, so all the masses are the same again. I cross out all the masses. Initially, both of the balls are not moving in any y direction, so those will cancel out. They'll equal to 0. Okay, and v1 final is moving in the positive direction, so that'll be positive, and we already know the value for that. It's going to be 4.33 sine 30. And v2 final is moving in the opposite direction, so it's going to be minus v2 final. Right? So we're going to solve for v2 final. Let's move it to the right, to the left side. V2 final equals 4.33 sine 30 degrees. That comes out to 2.165 seconds. That's in the y direction. So now we know the components for ball 2 after the collision. So we're going to draw it out. So this is how ball 2 moves. You know the x component, it's 1.25 meters per second. You know the y component, it's 2.165 meters per second. And we're solving for theta. Solving for V2. So now we're going to solve for theta. We're going to use tan for theta. So theta equals opposite over adjacent. So 2.165 over 1.25. Theta comes out to be 60 degrees. Okay. Now we're going to solve for V2 final. And V2 final, we can use the Pythagorean theorem for that. So V2 final squared equals 0.25 squared plus 2.15 squared. V2 final equals 2.5 seconds. Okay? That's part A. Okay, so part B asks whether the collisions are elastic or inelastic. Well, the collisions are elastic because of the way billiard balls behave with each other. They don't stick together, first of all, when they collide. And then if you use the conservation of energy and the conservation of momentum equations, and you plug in all of the values for that, it'll be the same on each side. I don't really want to do that. This video is already 6 minutes, 7 minutes long. So yeah, they are elastic for part B.